How do you apply Ohm's law in series and parallel circuits? Imagine you're trying to understand how electricity flows through different paths and how voltage and current are shared. That's where Ohm's law comes into play, giving us a simple way to analyze circuits. It states that the voltage across a resistor equals the current flowing through it times its resistance. The formula is V equals I times R when working with series and parallel circuits. The way voltage, current, and resistance behave changes, so we need to adjust our approach. In a series circuit, all components are connected one after another, forming a single path for current. Because of this, the same current flows through each resistor. To find the total resistance, you add up all the individual resistances. For example, if you have 3 resistors of 10 ohms, 20 ohms, and 30 ohms connected in series, the total resistance is 60 ohms. Once you have this total resistance, you can find the current by dividing the total voltage supplied by the total resistance. If your power supply provides 12 volts, the current is 12 volts divided by 60 ohms, which equals 0.2 amperes. Knowing the current, you can then find the voltage drop across each resistor using Ohm's law. For the 10 ohm resistor, the voltage drop is current times resistance, so 0.2 amperes times 10 ohms equals 2 volts. Repeat this for each resistor to see how voltage divides across the circuit. In a parallel circuit, all components are connected across the same 2 points, giving multiple paths for current. The voltage across each resistor is the same as the source voltage. For example, if your power supply is 12 volts, each resistor in parallel sees 12 volts across it. The total resistance in a parallel circuit is found using the reciprocal formula. 1 over the total resistance equals the sum of 1 over each resistor's resistance. So, for 3 resistors of 10 ohms, 20 ohms, and 30 ohms, you calculate the reciprocal of each, add them up, and then take the reciprocal of that sum to get the total resistance. Once you have the total resistance, you can find the total current by dividing the source voltage by this total resistance. To find the current through each resistor, you divide the voltage by the resistance of that resistor. For the 10 ohm resistor, the current is 12 volts divided by 10 ohms, which equals 1.2 amperes. The currents through the other resistors are calculated similarly. The total current supplied by the source is the sum of all these branch currents. Applying Ohm's law in these circuits helps you understand how voltage drops and current distribute. In series circuits, focus on adding resistances and calculating the current first, then find individual voltage drops. In parallel circuits, determine the total resistance first, then find the overall current and individual branch currents. When circuits combine both series and parallel parts, carefully identify each section and apply Ohm's law step by step. This way, you ensure your calculations match the actual circuit behavior. Knowing how to do this allows engineers to design safe, efficient electrical systems, whether for simple devices or complex machinery.